Hey, I'm back with a brand new study just conducted by the Harvard Medical School and published in the Journal of Nutrition. In this study, they took 72 overweight adults, both men and women, and they studied them for 20 weeks. They randomized all of these people into one of three groups, and they actually provided all of the food for this study, so it was very well controlled. Now, in this study, they had the exact same protein amounts given to all of the groups. They all got 20% of their total caloric intake in protein. What they were varying was the amount of carbohydrates and the amount of fat. So they had a high carb group that was 60% carbohydrate, 20% fat. They had a moderate carbohydrate fat group that was 40% of each, carbohydrates and fat. And they had a low carbohydrate group that was 20% carbohydrates and 60% fat. Now, they actually conducted brain MRI scans of the reward center of the brain to determine how the different foods were affecting their brain reward system. They did an MRI in a fasted state before they've eaten anything every day, and again 4 hours after their first meal every day. What they found in the high carb group was that they had 43% more blood flow after their meal, 4 hours after their first meal every day, when compared to the low carbohydrate group. And they even had 41% more blood flow in the reward center of the brain, even in the fasted state, again, when compared to the low carbohydrate group. Now, this sounds like it would be a good thing, right? More blood flow sounds great. But this is more blood flow in the reward center, which means they're getting a bigger reward every time they eat the carbohydrate-containing meals. Now, we know when it comes to groups like drug users that they have to take more and more and more of the drug to get the same response or to feel the same reward. Well, this is the same thing that's basically happening here. They actually have a weakened reward response, so it takes more and more and more food to generate that reward, potentially leading to overeating or even some food addictions. And they found this both in the acute state, 4 hours after the meal, but also in the chronic state. They stayed in the elevated blood flow state, or the reduced reward state, even in the fasted state when they weren't consuming food. So they were already prepped to need more food to get the reward from the food. So, of course, more research is needed. In this case, they were giving them all of the food. So what does this look like in normal life when they're making their own foods and they're making their own choices? What does it look like when you change up the quality of the food? Or when they actually are getting to choose what plan they're following? In this case, they were randomized into the groups, so they weren't necessarily following a plan that they personally would choose to do. And what happens if we vary the protein levels? In this case, we had stable protein across all three groups. But what happens if you have more protein or less protein than the standard 20% they used in this group? It's so fascinating to see what physical changes the food is making on the brain and how this can potentially lead to addictive behaviors. So I'm sure there will be more research coming on this, but I thought it was fascinating, so I wanted to share.